All right, today we're going to be looking at section 5.1, inverse functions. We have two objectives to tackle. The first is determine whether a function is one-to-one, and if it is, we're going to find the formula for its inverse. And then two, we want to simplify the expression of the type, and this is f composed of f inverse, and then we want to do f inverse composed of f. So we start talking about inverses. We start out with inputs and outputs when we get a relation, okay, just a set of ordered pairs. So here's a relation H, and this is the following. And it says, suppose we just interchange the first and second coordinate. This would be called the inverse. So all we're doing is interchanging x and y. So we swap the order of the ordered pair, and that gives us just the basic format of inverse. So then here's a definition of inverse relation. So if you just have a relation set of ordered pairs and you interchange them, you get the inverse. Now, likewise, if we have a function, if we want to find the inverse, we're going to do the same. So here's an example. They show you have y equals x squared minus 5x. We're going to interchange the variables. So y is going to be replaced with x, and the x's get replaced with y's, and then we solve for y. So this example goes through that process. It shows you ordered pairs, and the same thing happens with those ordered pairs or relations. Inverses and one-to-one functions. We'll get to talking about what it means to be one-to-one. Let me get to there. So here's that definition. A function is one-to-one if different inputs have different outputs. And usually what I tell people, each x value is paired with one and only one y value. This is the mathematical term. So this is, a is not equal to b, f of a and f of b are not equal to. So you got two different x values. They're going to give you two different y values. The inverse function f, the inverse of a function f is also called, or is named f inverse. So f raised to the -1 power is read f inverse. It's telling you the -1 or the -1 is not an exponent. So this is just the notation for inverse. Then you have just some more definitions. So it says if a function is one-to-one, then its inverse is a function. The domain of a one-to-one function and the range, the domain of a one-to-one function is the range of the inverse. So again, if you swap x and y, the same thing happens with the domain and range. And then it says a function that is increasing over the entire domain or is decreasing over the entire domain is a one-to-one function. So those are just some of the properties and things that you want to be aware of. If you're looking at a graph and you want to know, is the graph a one-to-one function, we do what we call the horizontal line test. The horizontal line test, it just says if it is possible for a horizontal line to intersect the graph of a function more than once, then the function is not one-to-one. So like if I was just to draw a line straight across anywhere horizontally, it should only cross one time. We have a vertical line test. We also now have a horizontal line test. So this would not be a one-to-one function because we have, you see, A corresponds to whatever this y value is, and B corresponds to the same. So that means each x value is not paired with one and only one y value. So you can do several of them with horizontal line tests. And you can kind of see some of those properties. This is not completely decreasing the whole way. It starts decreasing and then it goes increasing. So anytime you see a change, it's probably not going to be one-to-one. And then we just kind of have an overview finding formulas. It tells you replace x with y, interchange them, solve for y, and then you replace y with f inverse. So we'll do that with several examples in my math lab, and they're showing you some examples here. It also lets you know that the graph f inverse is a reflection of the graph of f. across the line y equals x. So we'll kind of see some of that. Here's an example of that. You got this dotted line is y equals x. You have f. You have the inverse. And you kind of see they're like mirror reflections across this line. That's what this property is describing. And then you have a couple of more examples, and then we start talking about inverse, function, and composition. And so one neat property that you want to know is if a function is one-to-one, then it has a inverse is unique such that each of the following holds. So if we take the inverse and we compose it of the original function, we're going to just get x. Same thing if we do the original function, compose it with the inverse, we're just going to get x. And that is for each x in the domain of f, and that's for each x in the domain of the inverse. Here's some examples provided. You also need to be aware in the case where the inverse of a function is not a function, the domain can be restricted to allow the function, the inverse, to be a function. So some functions are not one-to-one functions, but we can restrict them so that they are. So that's what this is mentioning. All right, so let's jump into my math lab and do some problems.